Okay, so in this video we are going to discuss exercise 8.4. Okay, problem number 2. Let's read what the problem is. Write all the other trigonometric ratios of angle A in terms of sec of A. Okay, so we know that there are 6 trigonometric ratios, and now this question says that except sec of A, so 5 will be remaining, all of them 5 should be expressed in terms of sec of A, some expression of sec of A. So first and foremost, let's list down all the 6 trigonometric ratios. Okay, so we have sine of A, okay, then we have cos of A, and then we have tan of A, and then we have sec of A, we have cosec of A, this is sec of A, and then we have cot of A. Okay, so thus we have these 6 trigonometric ratios, and each of them has to be expressed in terms of sec of A. So that is our question for this. So sec of A is sec of A, so that I will just write as it is, and the rest has to be expressed. Now first let's write down the obvious one, which is cosec of A. Okay, sorry, which is cos of A, because cos of A is nothing but the inverse of sec of A. It's a reciprocal of sec of A. So cos of A can be written as 1 upon sec A. Okay, so cos of A is done. Now since we have cos of A, we can easily write sine A in terms of sec of A. Why? Because using the trigonometric identity. So I'm going to write here trigonometric identity, trigonometric identity. We have a trigonometric identity which says sine square A plus cos square A as equal to 1. Okay. Now we have cos A in terms of sec A. So let's substitute that value, and therefore we have sine square A plus 1 upon sec square A as equal to 1. Okay, now let's try to solve. So therefore we have very quickly sine square A as equal to 1 minus 1 upon sec square A. Now let's try to solve this. This is sec square A minus 1 the whole upon sec square A. This is our left hand side, which is sine square A. Now taking square root on both the sides, we have sine of A as equal to under root of sec square A minus 1, this is square root, the whole upon, in denominator we have sec square A, so square root of sec square A will be just sec of A. Okay, so this becomes, let me use just a highlighter, so this becomes sine A expressed in terms of sec of A. So let's zoom out and make a note of it here. Yes, so it is basically equal to under root of sec square A minus 1, okay, the whole upon sec of A. Okay, so let's again zoom in. Yes, so this is our sine A expressed in terms of sec of A. Now since sine A is expressed in sec of A, we can express cosec A in terms of sec A, because cosec A is nothing but 1 upon sine A. In fact, I'm going to write it down. So cosec A is equal to 1 upon sine A by definition, and that is equal to, so 1 upon sine A will be reciprocal of this expression. So that is nothing but that is nothing but sec of A the whole upon under root of sec square A minus 1. Okay, so thus cosec A is also expressed in terms of sec A. Now what remains is tan A and cot A. Once again, by definition, tan A is nothing but sine A divided by cos A. So I'm going to write it down. Tan of A is nothing but sine of A divided by cos of A. Now we already have both sine A and cos A in terms of sec A. We are just going to perform their division. So this term divided by this term. So as you can clearly see, sec A in the denominator, they will cancel each other. So tan of A is just going to be under root of sec square A minus 1. Okay, this becomes our tan of A. And now once again, what is cot of A? Cot of A is reciprocal of tan of A. Okay, and thus that is going to be 1 upon under root of sec square A minus 1. Yes, and thus we have very successfully here, okay, we have expressed all the trigonometric ratios, all these 5, Okay, sec A is sec A, but the remaining 5 trigonometric ratios are expressed in terms of sec A only. So that is what is this question about.